This is GMAETS 41. Welcome to this channel. In this video, I am going to show you how you can solve this integration problem on the board. This is question number 2. In question number 1, I already told you that I was going to release 15 sets of questions that are U-substitution problems and how you can attack these questions using super shortcuts as I will guide you. So we're going to look at this question number 2. But you know what? For you to appreciate what the GMAETS 41 has decided to do, releasing these 15 sets of questions, I'm going to solve this problem using 2 methods. One, the general method, where you stress yourself, reversing chain rule, saying let you be something and something and something, and you do something. Of course, that is what most of you are going to see in your lecture halls. However, you're preparing for CBT examination, that general method is really uncalled for. I'm going to show you the general method and then I will teach you quickly how you can obtain this result without going through the stress of the general method. Please, come on, let's look at method 1, general method. In that general method, the question given to us is integral x squared all over 2x raised to the power 3 plus 7. We are integrating with respect to x. Now, I look at this clearly and then I observe that if I differentiate this denominator, right, it will give me something close to the numerator. Yeah, if I differentiate this is going to be 6x raised to the power 2. And good enough, the variable there, x raised to the power 2, is what you have in the numerator. The difference is just the 6 you obtained when you differentiated this. Watch again as I do the differentiation of this term. 2x raised to the power 3 differentiated is going to give you 6x raised to the power 2. This is going to be 0, that is derivative of 7. Observe this x raised to the power 2. That is exactly what you have in the numerator. The difference between the derivative of the denominator and the numerator is just that the derivative of the denominator produced 6. Now I'm going to tell you clearly what the answer of this integral is without solving anything further. But like I said, I'm going to teach you the general method first. But just have it in mind that whether I use the general method as the case might be, the answer I will get here from what I observed is going to be 1 over 6 ln of 2x raised to the power 3 plus 7. Look at it. 1 over 6 ln 2x raised to the power 3 plus 7. Then plus constant of integration. This is the answer I'm going to get. All right, let's move on. So for this, we are going to say let u be equal to the denominator 2x raised to the power 3 plus 7. Now this is to allow us solve this question in terms of u. With this assumption that I made, I can remove this whole denominator and fix u. All right, since u depends on x now, as you can see, we have to differentiate that u with respect to x because u depends on x. If I differentiate this term, which is the u term now, I am going to get 6x. Remember, like I said, the whole idea of U-substitution technique of integration is just to remove all the x we have there as much as possible and replace it with u. Then again, this differential coefficient, dx, find a way to kick it off and fix du. So how can we achieve that? From here, I have various choices. I can decide, please, this derivative is 6x squared. 6x squared. I can decide to make du subject to the formula, which will now give me 6x squared dx. Of course, if I have 6x squared dx, x squared dx alone can be replaced if I want to. I can decide to make dx subject to the formula, where I will get du over 6x squared, which will allow me to substitute for this dx directly. I can decide to say, okay, let me make x squared subject to the formula, which will now give me du over dx, then 6 will be in the denominator. Once again, x squared will be du over 6 dx. That will allow me to come to this function, then remove x squared and fix du over 6 dx. And that dx, we cancel this dx. The whole idea, once again, like I said, is to help us solve this question using u and du. So the choice is now yours, whichever you want to make subject to the formula. For me, I would prefer to make dx subject to the formula, so I can just remove this dx directly. So from here, it implies that dx is going to be equal to du divided by 6x squared. Now, I have my u here, which I'm going to replace for this denominator. I have my dx, so I can replace for this dx. Let's do that. The implication is that this integral given to us, x squared all over 2x cubed plus 7 dx will now be equal to integral x squared and all over, this will now be u. Then come to this dx. dx is du divided by 6x squared. I've done the substitution, right? I substituted for this dx using du over 6x squared. I substituted for this 2x raised to the power 3 plus 7 using u that we selected for it. With this substitution, you observe that this x squared will cancel this x squared. So we are left with, let me complete it here. This is going to be equal to integral du over 6u, du over 6u, right? Now, normally we do not integrate constant. So this constant 6 is going to be pulled out of the integration sign. So this is going to give us 1 over 6 integral du over u. This is super cool. Once again, in that question number 1, right, in the 15th set of questions under U-substitution, I want to show you the super shortcut. I had explained that once you differentiate the denominator and get the numerator, the answer of that integral is simply ln of the denominator. And that's what we have here. The denominator is u. If you differentiate u, you're going to get du. That is exactly what you have in the numerator. So this is now going to be 1 over 6, then ln of the denominator, which is ln u, plus c. We have gotten our answer. Conclusion, therefore, the integral given to us, which is integral x squared all over 2x raised to the power 3 plus 7 dx is now equal to 1 over 6 ln, what is our u? Look at it, 2x raised to the power 3 plus 7 and then plus c. This is the result using the general method. But I don't like this. And you will not want to do this in examination hall. Avoid it as much as you can. Stay tuned and follow the series of 15 questions I'm going to release under the super shortcut method of solving U-substitution problem. You will love it. This is going to be your stronghold in the examination if you're exposed to any integration problem. I guess you've seen this, right? I don't know whether you like it or you don't like it. In either case, there is a short way you could have solved this. Nothing is there. I'm going to wipe this general method now so that I'll show you the super shortcut you could have used, okay, in the exam hall. Of course, while you prepare for your CBT exam. Super shortcut method. Of course, using the standard for U-substitution. You are given this. What do? Observe that the numerator and denominator, they belong to the same class of function. They are both polynomials. Therefore, quickly differentiate the denominator and see what you're going to get. We've talked about that again and again. If you differentiate the denominator, you will get this. Good enough, you have this x squared in the derivative, and that is exactly what you have in the numerator, right? So the derivative of denominator produces what is in the numerator only with a difference of this constant number 6. Therefore, the answer of this integral is 1 all over that 6, which is the constant difference when you differentiated the denominator. Then ln of the denominator, and the denominator is this term, 2x cubed plus 7. Then plus constant of integration, c. And you see, very simple, this was the result you obtained through the general method. Get ready for question number 3. You're going to find that in the YouTube short section of this channel. Subscribe, turn on the notification bell, become a channel member, stay tuned so that you can learn more from this channel.